Alright, more folks, going to continue on with our mass movement. So these are the videos I'll be posting through YouTube onto your class summary page on Plus Portal. Okay, there'll be relatively short videos, probably 1 or 2, usually 2. They will include all instructions that you need and go into any assignments and stuff, so you can see exactly what you need to do. Alright, today we're going to start. You're going to need to go into Google and type in something called classification of mass movement. You should be able to see it here. Alright, my computer is very slow. Classification of mass movement, and when you search that, again, as I said, it's very slow here. We'll be taken to something like this. Okay, you can go straight into images. Okay, and then when our images come up, I want you to scroll down through. A lot of it's very complex, don't worry about that, but we have this one just here. Now actually what I found is we're going to do a sketch of this in just a moment, but if you click on that again, it actually takes you to a very, very good website which has lots of information about mass movement, and the types and the problems and stuff with it. So I'd actually encourage you to maybe write down the link for this. I've never heard of NeoStencil before, but I will be looking it up in future. I would make a note of this link under where you've headed up, okay, and or beside where you're about to do the sketch, because it talks about all sorts of things. It's got, this is way more detail than we need, but we got a weathering and erosion from different topics. Okay, and as we go down, more stuff about weathering, types of weathering process, chemical, hydration, I don't know what that is, hydration, oxidation, all this kind of stuff. Okay, exfoliation, pictures, some really, really good stuff, biological mass movement, and then we're looking for this classification. So once you come down, you should see this diagram here, and again, under where you've headed up, I'll put the headings that you need in the email about the work. Okay, but I want this diagram here sketched. All right, again, I would make a copy of the link for this website up here so you can review it for a little bit of revision, because we'll be finished this topic very soon. All right, now you've got a couple of different things. Okay, you got heave, don't worry, we haven't seen that word yet. Flow and slide. Okay, so we've seen mud and earth flows, you've seen landslides. All right, a heave is more, again, a slower movement, so I'll talk about that in just a moment. So you got those 3 words on your triangle. Now along 2 axes, you've got the bottom axis, you've got move or speed, from slow to fast. Alright, so heave will be relatively slow. As you move along this axis towards landslide or whatever, it is, speed increases. We've also then got dry to wet. Okay, so how much liquid or water is held by the material. So again, driest down here, moving all the way up to our wettest up here. Alright, within that then you will see a lot of words we've already talked about. Okay, soil creep, solifluction, rockfall, that should be rock slide. If block or rock slide, I would change that to rock slide. Now rotational slide we look at, you can also put rotational slide / slump here, please. Okay, and we'll look at that in about 10 minutes. Earth flow, mud flow, avalanche, you can add it in. We don't really focus on that in geomorphology, but you can add avalanche up here. Okay, so then what we have within, and again, use a ruler please, we've got these kind of categories. So the triangle actually is full of a number of different areas. The slower ones, soil creep and solifluction, okay, they'll be down this side down here. Okay, then we start in terms of speed. These are the faster ones. All right, mud flow is actually probably the fastest. It's the closest to this black line, this axis here. A rockfall is very fast, very dry. There's very little water involved in a rockfall. Okay, the rest of them then, mud flow is a lot closer to the wet end. Okay, it contains a lot of water, but it's also very fast, so it's in this. So we go, speed comes up fast over wet. Okay, so mud flow and earth flow would be up there. The slumping and rock slide are in between. Again, they can depend how much water they contain, but both are very fast. So as we move this way, they get faster. As we move this way, they get slower. This way, they get drier. This way, there's more water involved. Okay, so you can pause the screen, all right, and have a little sketch of that, nice and big. And when you're finished, I want you to go to this worksheet. I'll add the scan into the email again. All right, it's in the same folder as, let me just scroll up for you. That was the first sheet on it. Okay, then the question sheet. We're going to look at this next. All right, so change over that and then I'll continue. Okay, so continuing on then, what we're going to need to do is you'll need a blank folder sheet, or if you've done your notes on one side, on the back side of this, we're going to need to sketch our 6 little diagrams from that worksheet I just showed you on the scan. Okay, so I start off by dividing my page up into 6 even pieces. There were 6 diagrams. All right, you'll notice there's one down the bottom corner code that just says slump. All right, you can put an X through that one. I'll show you another example in just a moment. These are not overly difficult to sketch, and remember, this isn't art class. What's important is the labels we're going to add to each one. In the top left corner, the first one said soil creep. All right, so I put soil creep in this little area, and then I begin to draw it very, very quickly. All right, again, does not need to be a masterpiece. All right, it's got a little tree in here. We've got branches coming off over here, and you got vegetation like that. It's got a leaning pole, like so. Then it shows its layers. Okay, one important piece is this line below, and then everything else is the geology below it. Okay, so if I'm to run over that in pen, you saw that only took a couple of minutes, not even, to sketch. Okay, so come up, we are a light post. Alright, so this is the quality I'm talking about. It's nothing overly difficult. Draw that down, bring that over. Okay, our little tree with our foliage, lovely. Okay, alright, now the important bit is to make sure you got this first layer under there, okay, and it will continue along over there. After that, it's just the layers of geology. So again, you can see from the diagram, it's not overly difficult, okay. And then I suppose it's got the little lines to show the direction of the slumping. All right, so that is, let me just soil creep. Okay, so you can see, oops, that's what the first one should look like. I've divided my page up into 6. Trying to show you. Sorry, the dogs are going mental. Here's one that I did earlier. Okay, with my 6, I got my soil creep, rock fall, rotational slip, rock slide. The slump one, I've put an X through it, okay, because we don't need that, and mud flow. All right, so again, not overly complicated, just some quick little sketches like so. What I'm going to do now, the important bit, as I said, is adding some notes to each of these. All right, so what I'm going to do very quickly, I'll add some notes. I'll pause the video, add the notes to these 2. All right, unpause it so you can see. I'll go through it and then do the next 3 after that. All right, so we'll take it step by step. So I'm just going to pause for a moment and come back to you while you sketch. All right. Okay, so just to resume then, all right, I've just updated my first 2, all right, so you can see my soil creep, I've added some little notes, and for rockfall, added some little notes, annotations. So you can pause the video, okay, and add those. I'll talk to them very quickly. In our soil creep here, you can see the different layers of the geology, okay, so they're shown by these lines here. All right, this is the bedrock. It's the top layer. So the top layer of soil is all that moves. So it's this top layer. So the quantity of material isn't exactly huge. All right. I've put in an orange arrow, my highlighter. This is the slide plane. This is the slope it takes. All right. I've put 2 more little arrows up here just saying slow movement. You could add in gentle slope. All right. Nothing too severe. We'll contrast that directly with rock falls in a moment. Some impacts. trees bend, walls crack, lampposts move. Okay, so the trees will start to bend with the slope, lampposts moving. I don't have the artistic nous or quality to draw that wall, so I skipped it. All right, over onto our rock fall. A couple of different things then. This first little arrow up in the top corner, free face. It says, okay, 70-degree angle or more. So when you contrast that with this, all right, the first piece of movement along the plane is incredibly vertical. All right, up along here we get our freeze thaw action occurs here to weaken the rock. All right, so that's where the weaknesses and stresses would have appeared, and then the force of gravity pulls it down. That's all it is. Material at the bottom is called talus. Okay, T-A-L-U-S. All right, so that's our first two done. All right, I'm going to add notes to the next three, and then I'll come back to you. Okay, so look, just to finish off, okay, rotational slip, again, you'll notice my orange arrows on these two, okay. Rotational slip, I want to add the word slump first of all, because the bottom left one you don't have to draw. We're not going to put that in, okay. Now, mainly clay or heavy soils, okay. We've got this curved slide or slip plane, all right. And you can see the way it kind of curves down almost in steps. We've got this slipping or slumping motion, okay? Think of slumping down in your chair, the way you kind of curve down into the chair, all right? It happens near coasts or oceans quite a bit and can happen in stages. So you can have the first bit slump, then the bit behind it slump, and so on, all right? So you're left with this almost terraced landscape. Very quickly, just to do the last two, rock slides, you should be able to see everything there. Speed depends on the angle of the slope, okay? And the big blocks that break off, they maintain their shape until impact at the bottom of the slope. So you can see the geology here is very obvious. Weaknesses and cracks in the bedrock, okay? So cracked, weakened bedrock or geology. They will, as they come to the surface, okay, as each layer is broken away, they'll break into these big slabs which maintain their shape as they slide down and then break apart. The little faces left behind in the rock are called scars, all right? And you'll see that word scar again in our mud flow. A scar is the empty space left behind. So when all the mud material and soil flows downhill, it leaves a big scar behind, all right? The majority of the material is very, very fine soil, and it's highly fluid and fully saturated with water, all right? Then the last bit, the front of it is called a toe, just like an avalanche. The toe of the flow spreads out and it will cover everything. So just like this was what happened in Italy in that Sarno case, this flooded down, okay, quite quickly. Look back at your classification pyramid. It moved down very quickly and then it spreads out and covers everything, okay? So these are your notes for today. There's no assignment, but I want all this done out in folder sheet and put in your binder. All right, folks.